All right, lesson 6.3, we are going to be learning about radicals and rational exponents. So when we're talking about b to the n is equal to a, for an integer n greater than 1, b is considered an nth root of a. So this means that the nth root of a is equal to b, okay? Because we're taking b, raising it to a power of n. If we then took, and that equals a, if we then took the nth root of a, we would be right back. So these are going to be called like inverse operations of each other, but that n, now we're going to be working with things greater than a square root, cube root, fourth root, fifth root, and so forth. When we're talking about nth roots of a number, they may be real or imaginary, and we're going to study the imaginary numbers in a future course, so we don't have to worry about those today. All right, so this is the example from the textbook. To simplify each expression, you basically are looking for the cube root of 64. So what, as a factor of itself, 3 times is equal to 64? I'll show you a function on your calculator that'll help you calculate it. But basically 4 times 4 times 4. So the answer is 4. The cube root of 64 is 4. In B, the fourth root of 81. We're talking about, what times itself is a factor 4 times. So 3 times 3 times 3 times 3. So the fourth root of 81. I might have said 84. I'm sorry if I did. 81 is 3. Now, here's a study tip. We're talking about understanding what these roots and everything mean. And when we have an even index, and this is the index right here, these actual values could be negative. Okay, that's the only time you're going to be allowed to have a negative under the radical symbol when you're talking about that, because this could easily be negative 3, because negative 3 times negative 3 times negative 3 times negative 3 is also a positive 81, right? So it's the same value and it's still a real number. That's what we're talking about between real and imaginary. So we're always going to assume that we're talking about the positive value because we're talking about the principal root, and the principal root is always the positive value. If and only if we mean negative 3, we would put the negative sign outside of there, and then we'd be saying we want the opposite of the principal value. Okay, a lot of words. All right, so when we're talking about rational exponents, now we can show our roots in terms of a rational exponent. So the nth root of a positive number a can be written to a power with base a and an exponent of 1 over n, or a fraction. We're going to have fraction exponents. So the fourth root of 81 becomes 81 to the 1/4 power. So that's like taking the fourth root, okay? In algebra, there's just an algebraic thing. So let's take a look at this. So when we see half, we're still talking about square root. So we're taking the square root of 41. 1/5 means fifth root. And notice that these right now are unit fractions, meaning they have a numerator of 1, okay? And then the index just becomes the denominator. All right, so we want to simplify the expression. Let's go ahead and do that for simplifying the expression. And we'll do it on our calculator, but you'll want to you'll put in 216, use the cube root function, and it should give you a 6. Okay, so if you're using this calculator, the order of the keys that you are going to press, you will press, because you have to put the index in first. So you will press the 3, then the button that says second, that'll activate all the little writing above all the keys. So 3, second, and then the caret, and that is the key that looks like this. That's the one that usually gives you the exponent or raises it to a power. And so above this shows this little symbol, okay? So we're putting in the 3, that puts in that index right there. All right, and so on the screen, you should see this 3, and then you see this, and then you see this, and then you see like a blinking box, and it's waiting for the number. So now we're going to type in 216. So to 16, and then enter, okay? And then the answer is 6. All right, that's how we got the 6. So this is the order that you do the keys, right? This is called the caret. I call it the up arrow thing. That's not proper. All right. So if we want to try number 2, doing the 5th root of 32. Okay, 5th root of 32. The answer is 2. 2 to the 5th power equals 32. All right, so 5, second, caret, 32, enter, and you get 2. All right, 4th root of 625. Go ahead and put that in your calculator. You should have gotten 5. Now we want to understand, what is this even asking for, right? It's 49 to the half power. Well, this is the unit fraction, so this 2 is telling us what the index is. So we're wanting the square root of 49, and we all know it's 7. Okay, here, unit fraction, so we're taking the cube root of 343. So you can follow along here, 3 second, caret 343, and it is 7. And here is the 6th root of 64, and that is 2. So 2 to the 6th power equals 64. So the 6th root of 64 is 2. Okay, moving right along. Now notice that they are no longer unit fractions, okay? So we'll kind of break this up. Let's write this as 64 to the 1/3 times 2, okay? So this allows us to take the cube root of 64, because that's what that means, the 1/3 power. Then we want to take it to the power of 2. So the cube root of 64 is 4. You can do that on a calculator, right? 4 squared is 16. All right, here, break it up. 9 to the 1/2 power times 5, okay? So that's the square root of 9 to the 5th power. All right, so we'll take 3 to the 5th power, and that equals 243. Here we have 256 to the 1/4 power times 3. So we'll take the cube root of 256, and I'm assuming that you're using your calculator to do these calculations. Then, oops, I just wrote that backwards. Where's my little eraser? Erase. That's a 4th root, because that's the 1/4, right? The denominator tells you the index. The denominator tells you the index. And then this is telling you then what you're going to do after that. Okay. So we're going to take the 4th root, which is 4. We're going to cube 4, and we'll get 64. So take a minute to write that down. Hopefully you understand that. I'm going to clear. All right. If we need to do a word problem in class, we can, but for now I'm going to skip this to save time for you. And we're already to the vocab and concept check. So remember, you're going to choose one or two. You're going to let me know which one you are responding to. Answer in complete sentences as best you can. I know that your ability to edit with equations, so use words to explain what you're doing. And do the best you can. Whenever you see a successful person, you only see the public glories, never the private sacrifices to reach them. You don't all see the hard work that goes behind all the success. So it always looks easier than it actually is. So a lot of time and energy and effort putting in behind the scenes to make all their goals attainable. So, and I'm not even going to try to pronounce that. So if you have any questions, let me know. Otherwise, I will see you in class tomorrow. Have a great night.